how to approach pricing for precision manufacturing. So I'm Harry, I'm the CEO of Phasio, and I'm here with Ludi, who is the Chief of Staff of Phasio. He is our German mad scientist, as you can see from the glasses and the haircut. As you know, Phasio helps manufacturers who are operating CNC, additive, injection molding, and vacuum casting facilities price their parts and get parts through production. In this, we're going to be talking to Ludi about some of the different pricing methodologies that can apply to some of these manufacturing technologies. And Ludi, I want you to start off with a little bit about, a high level on the most common problems you usually find that manufacturers encounter when they approach you to talk about pricing.
He does that all the time to me. But to be fair, I do have an interest in algorithms and also in pricing, especially for manufacturing, because those are such interesting problems to solve. Be it CNC, be it any kind of additive, there are multiple different kinds, of course, that work completely differently, or mold casting, right? All of these problems are multifaceted. There are simpler ones. Simple would be something in the powder bed space, an additive, MJF, SLS, and so on and so forth. Next level in simple would be SLA, for example, or FDM. But then it gets a bit more complex when we go to vacuum casting, even more complex when we go to CNC and injection molding. And the complexity arises basically with oftentimes people or manufacturing companies approach this topic with, oh, I want to have the exact price. But I want to challenge that idea and be like, there is no exact and super correct price. Simply because you give one part or drawing to one colleague and the same one to another colleague. And I bet with you that there will be two different prices. And then you do the same exercise 1 month later, and I bet again with you that you have at the end 4 different prices for the exact same part.
So your point is basically that different people would quote differently, and therefore there isn't an exact price. And so you need to establish a pricing methodology to be able to accurately price parts.
That's exactly right. Because nowadays often people quote based on experience, based on parts that they've been quoting before, based on their own manufacturing experience, based on their knowledge with the machines that they are working with. And it's not only the manufacturing process, it's also post processes, right? On the CNC part, what's my finish? Do I have the same finish on all sides of the part or another one here? Or is there post-processing attached to my powder bed parts? Do I want to have them dyed or whatnot, right? So it really is a bit of a more complex problem. But shall we approach those?
Yeah, can you talk through some of those different points that would have an impact on the price?
For sure. So some of these technologies that are firstly called a bit simpler, right? Those are very straightforward to produce a price for, right? But then others are a bit more complex, which might involve multiple steps. Take any form of casting, right? You got to make the master, you got to make the mold, and then at some point you gotta also make the parts with the mold, right? Sometimes you have such large quantities that you need multiple molds, right? Or you have multiple parts in one mold. So there are these sort of considerations that you have to make. And with these pricing structures, it's not that you have to produce a price. I upload a part, price is there, right? It's not necessarily the case. What you want is you want to estimate what the individual steps cost, and you want to be able to overwrite those estimates. And why is that estimate important? It's because you get your customers come in with an idea and they're like, hey, what would this cost? And then you have your engineers sit down and do the math and do this, do that. And then they come back and it's like, oh, that would be like $1,000. And then the customer's like, oh, my budget is 200. Well, bye-bye. And this situation is just a waste of time for everybody, for the customer who has waited for the quote, for the engineers that made the quote. So you want to get down to an estimate that's in the ballpark of the price. And if it's a large order with a large quantity, well, then it's worth spending the time, right? And really programming the machine, getting it down to the second, right? But only then, once the commitment to buy is there, to really get down to the precise price.
Right. So you've spoken a bit now about, the you could call it the technique of preparing a quote, of rather than trying to do it one shot, instead trying to have an iterative process. What about the individual pieces like the precision requirements of the customer or the lead times and even the customer's use case? How is that usually how do you usually manage that?
So I will do this on the example of the Phasio platform. And the Phasio platform has an area where you do requirement setting. And requirement setting would be all of that, right? Technology, material, and that could be based on the use case, right? And then there's precision, post processes, quantity, you name it. It depends on the different technologies, what options are available. But you would basically take all these requirements, and each of these requirements is somewhat connected in an equation. And in the equation, you extract information from the 3D model, such as volume, area, XYZ, those would be the simple ones. And then we have convex hull volume, shrink wrap volume, bounding box volume. You take the connection between them to get the complexity of the part. All sorts of information. How close is the part to a sphere, right? Really good for vacuum casting. How close is the part to, for example, a cube? Like less supports required or whatnot, right? And you, with that information, you can determine basically information. Oh, will take me a lot of time to polish the part afterwards or something like that? Is there a lot of internal complexity? Based on these, say, part informations, you can build algorithms, and there's not one true algorithm, but there are building blocks that you can always reuse. And think about like a template that just takes from 20 available building blocks, takes a unique combination of 6 building blocks, and that is your algorithm then.
So how does a manufacturer get started with this if at the beginning? Because it can be quite intimidating to go and start putting together these building blocks. Where do they start?
You definitely got to have a starting point, of course, right? And that is why Phasio provides algorithms that you can kick off with. And then we always say that these are the base, the fundamentals. And then you have to build on top of the fundamentals depending on your use case and on your company, on your machines, on your employees. And this is really the cool thing. The basis is there, and then adapted.
So that's Ludi, the Chief of Staff of Phasio, chatting about how to set up and establish pricing for within your precision manufacturing facility. If this is something that's of interest to you, then I highly recommend that you go to the Phasio website, you sign up for a free trial, and you check out these pricing templates that Ludi is mentioning here. We look forward to seeing you on the platform.